Today's problem is called valid Sudoku. So, what is Sudoku? Sudoku is a puzzle where these conditions are valid. First, every number has to be repeated only once throughout the row, and only once throughout the column, and only once throughout the grid, subgrid. So, we have this Sudoku is 9 by 9 Sudoku, and it's divided into 3 by 3 subgrids, like here. Um, let's see it. Okay, let's see it here. Um, say if I have here another 5, this will be invalid because 5 is repeated twice in my row and it is repeated twice in my subgrid. So this is two reasons why our Sudoku here is invalid. How are we going to approach this? First, our input will be 2D array of characters where it either have a number or a dot like this. So I will just iterate throughout my 2D matrix and see if my current cell is not equal to dot, then I'll validate. I have like a function say is it a valid row? Like I will loop through this like row and check is my 5 is repeated? No, then I have a valid row. Is my 5 is repeated on this column? No, then we have a valid column. Is my 5 is repeated throughout this subgrid? No, then we are good with the 5. And then we will move to the next element and then keep jumping to the next elements and so on until we reach the end. So there's just one small thing we need to discuss. Say if I am here at this say at this cell 3, this one, and I need to validate if 3 if I have more than one 3 inside this subgrid. How are we going to know this? I need to know like the start point, which is here, of my grid, and the end point, which is here. So I can need to like loop element by elements inside this subgrid and check if there is more than one 3. So the best solution here is to get like the beginning and the end is, say this 3 is 1, say my I here is equals 0, 1, 2, 3, 4, I is equal to 4, and j is equal 1, 2, 0, 1, 2, 3, 4, 5. In order to get this start point, we will need, say for I, will be equal to I minus I mod 3. This will give me the start I, and j will be equals to j minus j mod 3. This will give me the start j. And to get the end, it will be just the start I plus 3 and start j plus 3. So this is just like a small mathematical equation to keep it in our mind. And let's see how the code for this problem looks like. Well, let's first loop throughout the board. So for integer I equals 0, I less than board dot size plus plus I. For integer j equals 0, j less than board of 0 dot size plus plus j. This is how we like iterate through a 2D matrix. And here we'll check if board of I and j not equals to the dot. Dot means it's empty cell. We'll go check if is valid row. We will define these functions in a second, and we will pass the current I, J, and the cell, which will be board I and J. We will see the implementation in a minute. If this is a valid, I think we will say like if it's not a valid or not is valid call, we will pass I, J, board of I and J, or is not is valid subgrid I, J, board of I and J. Cool. I'll just return. Sorry, I made a mistake here. Yes. Return false. Otherwise, return true. See, looks good. Let's define these functions, but first I need to define like a copy of this board. So I'll have a vector, 2D vector of chars, 2D vector of chars here. Let's call it my board. And integer r, this is the number of rows, and integer c, number of columns. Let's have here my board equals to board, and let's have r equal board dot size colon equals board of 0 dot size. And let's define this is valid row. Bool is valid row. It takes integer I, integer j, and char c. And let's define the is valid call. Is valid call integer I, integer j, char c. And let's define also this one. Bool is valid subgrid integer I, integer j, char c. Good. So to make sure that we have a valid row, we will like iterate like column by column. How many columns we have? We have 9. Actually, we didn't need these two, which is just 9 by 9. But it's okay. Like we don't need even these two because they are 9 by 9 always. To validate the row, we will just iterate like column by column, and we will fix our like row. So it will be something like this for integer k equals 0. K is less than 9, or c plus plus k. If here c will be not equal k. I need to make sure that k is not equals to which one, I or j, row. K is not equals to I, because I don't want to go through, say I'm searching for 5, I don't want to search for 5 here because it's here. We're just searching for repetition. If k is not equal I and our my board not equals to c, here we will I will remain constant, and the variable here will be k. So if we're here at row 0, it will be 0 and 0, 0 and 1, 0 and 2, 0 and 3, 0 and 4, 0 and 5, and so on until 0, 9. So if this equals C, we return false. Otherwise, we return true. The same thing will go on the column here, this column, but the difference only will be making the this one will be the variable and this one will remain the constant. So we can copy this code here. This one is R. This one will be the variable we have, and this one will be our constant, because it will be something like, say, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, and so on. And we need to make sure that k is not equals to the column we are in, which will be j. If there is a bug, I will fix it. The subgrid, the small equation we talked about was integer start equals I minus I mod 3, and integer end equals j minus j mod 3. We loop for integer I equals 0, I less than I equals start, I less than row plus plus I for integer j equal star. Sorry, here start j start I start j. Sorry, here I will call them A and B. A star j, B is less than columns plus plus B. If grid, my board of A and B equals C, we return false. Otherwise, we return true. I need to make sure that I, J, I'm not standing at the same cell. Let's see, A not equals to I and B not equal to J. So if here, if I not equals to A and B not equals to J, we can proceed. Let's indent this a little. Let's see if it's running. Okay, we have a problem. Let's see where the problem happened. Return false. Return true. Not valid. Not valid. K not equals to I. So K is, say, yes, I'm sorry. Here it is start I plus 3, and here it's start j plus 3. Let's see. Still problem. So this was a bug. Also, start I, start j, A, B, B, B. I not equals to A and B. Alright, so the bug here will be the K is not equals to I. It should be K not equals to J, and here is K not equals to I. So what we are trying to do here is validate the row. So if say I'm looking for 3 here, I just need to make sure that while looping through the columns, I'm not going to loop through this column. I need to skip this column, which is J here. And here for the column, validate column, say I'm validating 7, while looping through these rows, I need to skip this row because I don't want to double check on the this 7 in this row. So if we run here, it's good, and we submit, and it's accepted. I will leave the code in the description. Thank you for watching, and I'll see you in the next video.